Hey everyone, so in this video we want to use what we learned so far and create a simple example, and that is, some Fruit Loops that come from a package and go into a bowl. Sounds simple, but we will run into a couple of problems with that. So everything is prepared already. We have our Fruit Loops here with a little bit of a material on it. So it's a normal material node that refers to a material network that I created here on SOP level, and in here are all the materials. I will share this file with you so you can have a look how I did it. It has a texture on it that you can get from textures.com, but it should be pretty straightforward. Then we have our box here, very simple, a thin surface, and then a bowl that we created the same way as in the beginning of the RBD chapter. So everything is there, and one last thing, I already created an animation which is in the Alembic here, which also will be linked on the side, and it has an animation on it where the box is moving up and then rotating around. Nothing special, nothing fancy, but enough for our needs. One small thing here, the actual animation is in the first couple of frames of the Alembic, but since I'm working in the frame range of 1001 to 1200 or something, I needed to use a time shift to offset the current frame so that it reads in the right frame range. But I think when you look at it, it will make sense to you. And before we start with this, let's quickly check the scale. I already have created Tommy here, and as you can see, it's actually a little bit too big. It should be, I don't know, a third of that or something like that. The reason I made it a little bit bigger is, of course, as we know, RBD or bullet is made for a certain scale, and it's a good idea to make it a little bit bigger to be closer to this scale so that the whole simulation will be more stable. We know there are solutions to make it more stable, but I think this is a good compromise between relatively accurate scale and a stable scale for the bullet solver. So let's get started. So the first thing is we want to fill this box here with Fruity Loops, and this is actually an interesting problem, and there are a couple of very complex ways of solving this, because you could theoretically already fill this box, for example, with points from volume, with a couple of points, and it might seem first to work. But when we increase the points, you can see it doesn't work, and the reason is the box is open. It doesn't represent a closed volume. So to do this, let's create a polyfill to fill the gap, and then it actually works. And here we could use a jitter scale, for example, to create a couple of points. But if you copy then the Fruity Loops on it, you will run into the problem that they will look through the geometry. So it might then look something like this. And when you actually look at it when it's inside of the box, you can see it goes through, and that doesn't really work. Now you could make this smaller by peaking the whole thing so that the box gets smaller, and then you copy inside something like this. This could work. That's not a bad idea. But if you would run this, you would run into the problem that the volume isn't covering it properly. And that's partly because as you can see here, the Fruity Loops actually intersect with each other. And if there's an intersection on the first frame, then the collisions will be ignored in the future. And this can result in a loss of volume. So one possible solution that is a bit more advanced, but I want to mention it in case some of you have seen a tutorial about this or something. There's a little trick where you can use an attribute called found overlap and set this to 1 on the first frame. And then the RBD bullet solver, as long as you set it to solve on creation frame, will instantly solve the collision. But then you have the problem again that the Fruity Loops will go through the box. So my point here is, yes, potentially there are very elegant ways of filling a box with those loops, but honestly, I would not make my life unnecessarily complicated, because often the simple solutions are the better ones. And that means what we can do here is we can just take a Fruity Loop, position it on top of our box here, there it is, and then we just let it fall down. So let's create an RBD bullet solver and simply use our box here as a collision object. So there it is, the fourth input. Be careful, it's not the fifth because that's the guide sim, but with the fourth input. And let's see what happens. So first of all, if we run this, Okay, the Fruity Loop falls down and then this happens. What could this be? Well, we probably guessed it already. This is because internally the collision object, weirdly enough, even though it doesn't show that, will be converted into a convex object. And we can visualize that in the bullet solver under visualization, and then not the active geometry, but the collision geometry, we can show the collision shape. And there we have it. And this explains what's going on here. Okay, so how do we solve this? Now let's make sure to turn it off again because it will make our viewport faster. To solve this, we know we can go under collision, and then here we have the collision shape. In a case like that, it actually makes sense to turn our collision shape from convex hull to concave. Let's quickly see how the whole thing looks like under visualization. We have to rewind, of course, and then you can see it actually takes the geometry. Now, I would not recommend doing this for the active object, but for the passive object, under collision, this can make sense. Now let's try that. And when we press start, we can see, yes, our loop falls into our box. So this is working. So now we can maybe try to create more of our loops. And this is straightforward. As we know, we can go to setup and then just activate emit RBDs. And then it looks like this. And now you can see it fills our box with loops. But we can instantly see a problem, of course. There's way too much space between our loops. What could possibly go on here? Well, let's have a look by visualizing our collision shape for our active geometry. And here you can see is the problem. The padding is actually way too high. So under collision, there's a collision padding for our static objects, but this is actually the padding of our active objects. So under properties, this is where we find our collision padding. And here, just play around with what works. Sometimes when it is too low, actually it creates more problems than it solves. But 005 worked pretty well for me. So let's have a look with that now. And if I press start, that looks much better. And now actually, let's make sure that we turn this off as we talked about, because that will speed up our viewport, as you can see. And now we can see we can fill our box here with our loops. Now there is still a big gap between the box and the objects. And of course, this time it is the collision padding of our box. So let's adjust this as well, maybe also to 005. Let's rewind and press start. Yeah, and this looks better. And now I think we have solved those problems. And now it's just a matter of letting this run for a while. Now you can, of course, adjust this a little bit by varying where the fruit loops come from. Currently, as you can see, when they are created, because they have created every frame, they're actually created inside of each other. But since our goal is not to show this in the render or anything, nobody will see that. And as you can see, once they are falling down, they kind of separate. So, you know, this is working. So let's not overcomplicate this for no reason. Now, as a technique that might seem a little bit too simple, but this is actually a very effective way of doing it, because as you can see, it actually is simulated relatively quickly. And what I like about it is it creates a pretty, believable distribution of pieces. So some are, turned to the side, some are not, and so on. It just feels believable. So this is actually a pretty reasonable approach to fill a box with objects. Just let them emit constantly into it and they will settle based on a simulation. This is a really good approach, and I actually used that in production before. So now to show the result a bit better, let's look through the actual geometry that comes out of the RBD so that we can see our loop properly, and let's also extend our simulation time. This is not absolutely necessary because, we will cache it later anyway, but it's a nice way of showing it at least. So let's run this, and here you can see what's going on. Now let's talk about a few problems here. First of all, I wanted to check how the box actually looks like, and then I realized, oh, this box is actually the animated version of our box. Now this is actually working currently because the animation of our box will be ignored currently because the RBD bullet solver under collision is using the collision type of animated. And currently, this is not an animated box, it's a deforming box. So we were kind of lucky that it didn't recognize our movement. Just to be safe, we could put in a time shift here and put it on maybe the start frame so that we will kind of throw away our animation, which later on we will use for the second step. But for this step of filling our box, we don't need that. And the second thing is, of course, and this is where I noticed that, when we now run this for long enough, and of course, I would always recommend jumping ahead in time and let the calculation happen in the background, so to say, because showing every single frame will slow down the simulation because just showing the geometry takes time. So this is why you should always just jump ahead in time and let it cook purely the simulation and look at the result afterwards. And of course, what we will see is that at some point our loops fill our box, but then they overfill it. So of course, what we will do here is we will stop the whole thing at some point, maybe at this frame 1480. So I built in here a switch node and say, when this is past frame 1480, in my case, it should switch to the second input, which is a null. So that means we only see a loop before that. And then it looks like this. It's filling our box here. And at the end, it just stops. We can let it settle a little bit and then we're good. And we have a nicely filled box, which didn't take too much time, but is a very efficient way to fill that box with our loops. Now, a small tip here to speed this whole thing up. What you could have done as well is to just take a line, for example, up here that is of course built of a couple of points, and then copy multiple loops on that. And then I actually use an orient attribute that I change every frame in the seed to create a different orientation for each loop every single frame. And of course, then when you have, like in our case, 5 loops, then the whole thing will be 5 times faster. So there's always a way of optimizing this workflow. And now we just need way fewer frames to really fill our box here. I actually will use our original version with a single loop because I simply believe that then the distribution will be a bit more interesting. I might be wrong here. No matter how you do it, the main question is, what do we do now with that? Because the idea behind this actually is to just create our start state before we fill this into our bowl. So all we need to do now is we have to cache this. So we use a file cache. And since this is only supposed to be our start state, we don't need to save the whole range. We actually really just need to save a single frame. And this would be the last frame that you basically like. Now, for my file caches, I prefer to use the explicit file path, and I already set a default here for my file cache, which you can do, by the way, here via save as permanent defaults. And I already set my path here like that. So geo, then the name of the hip file, and then a subfolder for the name of the node. And let's call this actually loops initial or something. And now we'll just cache a single frame, the one I'm currently on. There you go. And that was it. And now I have this on my disk. And I will read this in, of course, with a file node. So let's steal the path as an absolute path. And there we go. Now we have our start state for the next simulation. Okay, so now that we have that, let's actually start our actual simulation. We just created our start state for the actual bullet solver that we want to run now. And generally, keep in mind, whenever you use any result of one simulation in another simulation, I would always recommend to be very careful with the attributes. So in our case, it seems fine, but for example, we have V and W on our loops. And in other cases, we can have much more attributes that might potentially interpret it by our second simulation. And this is why you always should check your attributes and, in my opinion, delete what you don't need. Now, in our case here, it's not super critical because V and W, when you look at them, they have very low numbers, but nonetheless, let's make it a habit to delete everything we don't need. So we certainly don't need V and W. We can keep the name attribute. Let's see how that looks like. So it's piece 0 with a couple of numbers on it. This is okay. We already have a material on it, which is okay as well. Shouldn't create any problems. Maybe the detail attribute, let's make sure that we delete that as well, so that we can make sure that our simulation will not be influenced by anything that we don't want. So, okay, let's see what comes out of this now. And if we run this, well, first of all our loops fall down, and that's because there is no collision object anymore. So let's make sure we take our box, maybe directly without the time shift, because this time we actually want to have our animated version. So let's use that. And let's have a look what happens now. And okay, this is happening. So they fall through, but some hang in the air. So what's happening here is that we forgot that all of this stuff is based on certain settings in the first simulation, and the changes we made in the first one, we should apply to the second one as well. And we can actually visualize what's going on by just showing under visualization the collision shape, and there it is. We, of course, have to change the collision type to concave as well, so that it uses our box. But also remember, we actually changed the collision padding as well. Actually, let's see what happens with the old collision padding. Well, it seems to work, but nonetheless, the result will be better if we adjust the collision padding according to our first version. So let's make sure we use 005 for the box and our loops. Let's visualize that as well. There we have it. And now that seems to be much more reasonable. Okay, let's turn it all off so that our viewport is not too slow. And let's run this again. Okay, that seems to be reasonable. It settles a little bit in the beginning, but that's fine. We use a little bit of a pre-roll for this, nothing major. Generally, this is what we want. So let's bring in actually our bowl now. There it is. And also we want to bring in our animation. So let's bring our bowl by merging the two together. So at least that we have it already. Sometimes you have to reset the simulation to find everything. There it is. While we edit, we can actually quickly check how the collision shape looks like. And actually we're lucky because since we already switched to a concave collision geometry, this will apply to our bowl as well. Let's hope this doesn't create any problems. So let's turn this off. But what is missing currently, if we run this, of course, is the animation. We saw before that by default, it expects an animated version of our box. But what we have here is a deforming animation. So it's not an animated packed geometry. But we know how to solve this. We turn this into an animated state. And let's actually do this up here, not afterwards, even though that would work, but our bowl is not animated. So let's save that. And we use an RBD deforming to animated, which has the advantage of it will pack the whole thing as well, but it complains because it has no name attribute. So let's do this. So we could use an assemble for this, or maybe we just use a name node and call this box. And now it still shows an error. So let's turn it on and off. And then, okay, it seems to work. Let's see. Okay. So let's double check if that actually works. And you can see it creates a W, which is what we want. So it recognizes our movement. And let's now simulate the whole thing and see what happens. So it settles first and after some time, this is our simulation looks like. And that looks good, seems to work. While we edit, let's make sure we prepare this so that we only get our fruit loops. And then let's bring our geometry in. One way of doing this would be to create an object merge, or two actually. One for our box. I just copy it and paste it here. And then this represents the box. And the same for the bowl. There we go. And let's merge this together. And then there is our result. What we also could do potentially is we could, before simulating this again maybe, give all those loops a different color. If we actually want to have fruity loops, we could use a connectivity node for this, but we could also make it a bit simpler. Since we haven't packed our geometry yet, let's actually do this with an assemble node where we pack our pieces. Let's actually call them loops. I will turn off the create packed fragments so that we can keep seeing our materials here, even though it's more efficient in this case to use the packed fragments. And then we use a color node and create a random, or maybe actually we could use an attribute adjust color, set it to random, and then we have the advantage of using our own ramp if we want. I will actually use, let's say, two-tone. I think those colors are funny. And then let's sim this. Okay, so this is what we get right now. And I think that looks pretty good. I don't see any problems with this. The only thing I don't like is that the pieces almost seem like, you know, they're sticky. Like they really fall out very slowly as if they stick to the surroundings. And of course, there is a way of solving this, because here under properties, we can change the settings of our simulation. And I already played around with this. You know, I lowered the bounds and I actually increased the friction and checked how this looked like. Then I set the friction to 0. That then was too slippy. And what worked quite well was setting the friction down to 0.25. So let's give that a try by flipbooking this. Okay, so this is what we have right now. And I feel like this feels more realistic considering the amount of loops we have. What happens now, of course, is that loops fall over our bowl. So let's make sure that we're activating our ground plane. And let's run this again. And of course, there are 1,000 ways you could change the simulation, but I'm pretty happy with the way it is right now. Now, what you might notice is that some of the loops are moving over the ground in a kind of weird way, so they never come to a stop. This is something we will talk about in a later video. Just accept it for now. We will look in depth into this problem later on, but for now I think this is pretty good as a result. So let's cache this actually, because remember, always cache before you render. So we call this loops sim or something. Let's cache this out. Actually, the range that interests us is maybe just 1050 to 1250 or something. Our naming is correct because my defaults are changed. So let's cache this out. This should be relatively quick because it's already simulated. We just basically have to save it on disk. And with the cached version out, we could start shading this and rendering this. But at this point, I think we reached our goal. So what we saw are a couple of problems that come with a seemingly simple scene like that, mainly when it comes to collision. So I would say the main three things we covered here were filling a box with objects, and we had to split our simulation into two simulations for that, which is not that uncommon. And then we had to deal with the classic stuff like concave shapes and collision padding, and of course turning our animated box into an animated packed version of that box so that it's properly considered by the simulation. So I hope this is helpful. Thanks very much and see you later. Cheers.